Hello students, in this second semester of your SY-BSc Physics, the course which you have in paper 1, which is PHY-241, which is oscillations, waves and sound, correct? So I'll begin with waves now. So in your book, chapter number 4 is waves, correct? And chapter number 5 is sound. So today on 19th of March, I'll begin with the basic, starting off with the definition, then we'll see the types, and then we'll go again the definition of those types. So moment I use the word wave, starting off, waves means what? From your school days, you must be talking about or hearing about the waves as such. So basically, the waves usually you observed over a stretched string, or even the sound waves or the seismic waves. All these comes under wave motion. So what do you mean basically by wave motion? Wave motion is the motion of an oscillatory disturbance, correct? Through the medium is basically called as the wave motion. Now, the waves which travel continuously in the same direction, they will be called as the progressive waves. And when this wave travel through a medium, the particles of the medium perform vibrations about their mean positions. Okay, so if these vibrations are simple harmonic vibrations, then the waves will be called as simple harmonic progressive wave, correct? So now in this simple harmonic progressive wave, as we mentioned, if the vibrations are about their mean position, correct? So then if these vibrations are simple harmonic, they will be called simple harmonic progressive waves, progressive vibrations. Okay, so as far as the simple harmonic progressive waves are concerned, we observe the two types. First type is called as transverse, and second type will be called as longitudinal. Okay, even these words are not new to you as far as you being in SY-BSc Physics. Now, if at all I have to define transverse wave, how will I say that the waves in which the particles of the medium vibrate in a direction perpendicular to the direction of propagation of waves are called as transverse waves. Okay, where do you observe them? They travel through solids only. Okay, they do not travel through gases or other thing, liquids. Okay, and what is the basic example of this transverse wave? The best example is light waves. Second part we will define is longitudinal wave, very common now. So again the definition. So the waves in which the particles of the medium vibrate in a direction parallel to the direction of propagation of waves will be called as longitudinal waves. So difference is what? In case of transverse, you will observe perpendicular to the direction of propagation. As far as longitudinal, it should be parallel to direction of propagation of waves. So do this wave travel through everything? Yes, longitudinal wave travel through solids, liquids and gas, but these transverse travel only through solids. Then what is the example? I mentioned for transverse we said light waves, but for the longitudinal the example will be sound waves through the gases, correct? That's the best example. Or even as far as longitudinal is concerned, if at all you hold a spring in your hand, okay, suppose you hold a spring in your hand, and initially suppose your hand is not moving, hand is stationary, correct? So at that time you will just see a steady spring sitting over there without any vibrations. correct? But as you start moving this spring forward and backward, forward or back and forth we can say, then you will be able to observe what is called as the compression and the rarefaction. This is my compression and this is the rarefaction. So compression, rarefaction, compression, rarefaction, the pattern will be repeated. This is a best example which you must have come across many times as far as longitudinal waves are concerned, correct? Now we will move forward with what is called as the differential equation of wave motion in continuous media. In continuous media. So for that, what we can show first, we can just show a normal. I can show it over here that this is my y-axis, this is x-axis, and I observe the wave like this, correct? So this is point O, and I can show that at this point P, I just draw a straight line, correct? And then say that this is my phi, correct? So I can mention the diagram as wave pulse at time t is equal to 0, correct? Now if you continue this over here and show that my O will go to, this is again O, this is again my x-axis, and this is obviously my y-axis. So now I'll repeat this part over here, the first wave, okay? So in a dotted fashion. Then, so this is my first wave. Then I can show that the repetition will be observed over here and I will get a waveform like this. So this is my new origin O dash, perfect. This is point P. This will be phi, like earlier I showed you, perfect. And the distance from this origin O to origin O dash, I can join them and say this is CT. And distance from this O dash to P, this part will be X dash. And O to this P will be X, correct? So all these are clear in front of us. Now what we can say, suppose a pulse is traveling along the positive along the x-axis with the speed c. So my speed is c with which the pulse is traveling. It's traveling only along the x-axis, perfect. Then during the motion of the pulse, correct? So during the motion of the pulse, the particles of the medium vibrate about their mean positions, correct? So let the displacement of the particle will be phi, as I mentioned. This is my displacement. So I'll just mention over here, displacement phi. Now at time t is equal to 0, the pulse traveling along the x-axis can be represented by phi is equal to f of x, equation number 1. Perfect. Phi is equal to f of x. Now, after time t, correct? After time t, which means wave pulse at time, I can mention over here, wave pulse at time t. At time t. So, after time t, the wave covers a distance x is equal to ct, c into t. and at time t the waveform can be represented by phi is equal to f of x dash. Now why x dash? Because this is my x dash. This was initially at t is equal to 0, but after certain time t it has gone to the position x dash. So I mentioned it over here, x dash. Now what is my x dash? Basically x dash is x minus ct. This is x dash. This will be x minus ct will be x dash, or I can say x is equal to x dash plus ct. Fine. Now what is x? Basically again I'll show you. X is what? The distance of point P from O, and ct is the distance from O to O dash. Perfect. Okay. So now equation number 2. How will I write? I want to put the value of x dash now. So I can say equation number 2 becomes, correct, phi is equal to f. I'll replace x dash now by x minus ct. Equation number, I'll call this to be equation 3 and this to be equation 4. Perfect. Now what is this? Phi is equal to f of x minus ct. This is my general equation of wave motion. Correct? General equation of wave motion along, where it is moving, along the positive direction of x axis. Perfect. Now what I want, I need to differentiate this because I need a differential equation. So what to do? I'll say differentiate with respect to x. What? Equation number 4. So moment I say so means dabba phi by dabba x. I want differentiate with respect to x. So this will be f dash x minus ct. Correct? Differentiate again. I'll say dabba square phi by dabba x square is equal to f double dash x minus ct. I'll call equation number 5. Correct? Now what will I do? Here I have t also. So now I'll say differentiate with respect to t now, which means what? Dabba phi by dabba t. Here I have t. Correct? So what will I say? This is equal to minus c, because c is over here. I will use the word c for the speed. So minus c into f dash x minus ct. Differentiate again. What will I get? Dabba square phi by dabba t square is equal to, again I'll take one more c. So minus c into minus c will be c square f double dash x minus ct. Equation number 6. Now if you look at equation number 5 and equation number 6, what I can make the comment over here now, that dabba square phi by dabba t square is nothing but c square dabba square phi by dabba x square, because this value is nothing but from over here. Correct? So I can very with confidence I can write dabba square phi by dabba t square is equal to c square dabba square phi by dabba x square. That will be my equation number 7. So equation number 7 is dabba square phi by dabba t square is equal to c square dabba square phi by dabba x square. Equation number 7. Or other way is what? Dabba square phi by dabba x square is 1 upon c square. I can take this over here. So dabba square phi by dabba x square will be 1 upon c square dabba square phi by dabba t square. And what is this equation? This equation is nothing but differential equation of wave motion along x-axis. Along x-axis. Correct? So this was my, I should say, the first simplest ever topic, which was trying to find out differential equation of the wave motion in continuous media. Very simple but important as far as what we try to get over here by only taking the displacement to be phi and observe how the pulse is moving, wave pulse is moving at time t is equal to 0 and at time t what's happening. Only because of that we could solve this equation and we could reach to what is called as the differential equation of the wave motion along x-axis. Okay, thank you very much. See to it that you start watching videos sincerely, and after you watch the video, don't forget to write your name in the comment box, by which I will come to know that you have understood the lecture properly. If you have any difficulty, you have my number, you can please message me. I will be able to answer it to you. Okay, thank you very much.